ये स्क्रीन पे जे दिखत रहन इनखरा तो पहचानते हो जा, इनखर नाम मैक्सवेल बा। जेम्स क्लर्क मैक्सवेल इनखर पूरा नाम होइल, बाकी ऐसे शॉर्ट में इनखरा हम लोग मैक्सवेल बोली ले जा। इनखर बहुत सारा लॉ जो पढ़ले हुई वो मैक्सवेल्स इलेक्ट्रोमैग्नेटिज्म वाले में पढ़ले हुई, मतलब इलेक्ट्रोडायनेमिक्स वाले टॉपिक में जो है इनखर लॉ के बारे में काफ़ी ज़्यादा पढ़ले हुई एक्चुअली। ठीक है, तो इलेक्ट्रोडायनेमिक्स वाला टॉपिक में तो मान करके चली ला जा कि मैक्सवेल्स लॉ के ही इर्द गिर्द अधिकतर बातें के रहुआ जो है एक्सप्लेन कर सकीला। ठीक है, लेकिन आज हमने के जो पढ़े के बा वो मैक्सवेल्स लॉ ऑफ थर्मोडायनेमिक्स पढ़े के बा। हम मान करके चलते नहीं कि पहले रहुआ सब जे बा पढ़ले हो जा बेसिक लॉ ऑफ थर्मोडायनेमिक्स, जो कि जीरोथ लॉ ऑफ थर्मोडायनेमिक्स पढ़ले हो जा ना। फर्स्ट लॉ ऑफ थर्मोडायनेमिक्स पढ़ले हो, सेकेंड लॉ ऑफ थर्मोडायनेमिक्स पढ़ले हो और थर्ड लॉ ऑफ थर्मोडायनेमिक्स पढ़ले हो। ठीक है, बाकी फोर्थ लॉ तना पढ़ लें, हो सकता है रहुआ सब दे सकेला, लेकिन फोर्थ लॉ तो अभी तक नहीं जानल जा। थर्ड लॉ ऑफ थर्मोडायनेमिक्स तक हम लोग के सिलेबस में रहेला। अब एक एडवांस पार्ट हम लोग पढ़ब जा, जो कि मैक्सवेल्स लॉ ऑफ थर्मोडायनेमिक्स रहेला। ठीक है, तो एक में कुछ जानकारी रहुआ सबके पार्शियल डेरिवेटिव के बारे में, परफेक्ट डिफरेंशियल के बारे में थोड़ा बहुत होवे के चाहिए एक्चुअली, जो कि मान करके चलता नहीं कि ग्रेजुएशन लेवल में जो है थोड़ा बहुत होवे करिए रहुआ सबके। ठीक है, तो हमने के जो है ऐसे पहचान ली यही जेम्स क्लर्क मैक्सवेल हो, इनकर बहुत सारा लॉ एक्चुअली फिजिक्स में हमने के पढ़े के रहेला। ठीक है, तो हम लोग आज जो पढ़म एक्चुअली जो मैक्सवेल्स लॉ ऑफ थर्मोडायनेमिक्स पढ़ब जा। ठीक बा, कुछ लोग सोचत हो जा कि इस सर के कहा हुए एक्चुअली अचानक ही भोजपुरी में कहे बोले लगलन, तो कुछ स्टूडेंट सोचत हो जा अरे इस सर के होले कौन चीज, ये अचानक जे बा जे कहे ई भोजपुरी में कहे बोले लगल थी एक्चुअली। ठीक है, और भी पढ़ रहा लिए हम सब फिजिक्स वगैरह जो है एकरा में भोजपुरी बोले लगल थी, ये आप होले कौन चीज इनकरा जो है, तो ऐसे कुछ होले वगैरह नहीं एक्चुअली। ठीक है, भाषा तो मान करके चलिए कि जिस बातों से हम लोग अभिव्यक्त कर सकते हैं अपनी भावनाओं को, उसको भाषा बोलते हैं। चाहे वो भोजपुरी हो, चाहे वो हिंदी हो, चाहे मगही हो, चाहे वो इंग्लिश हो, चाहे तमिल हो, चाहे कन्नड़ा हो, इससे कोई बहुत बड़ा बातें नहीं रहा करता है। बात ये रहता है कि जिससे हम लोग अभिव्यक्त कर सकते हैं अपनी भावनाओं को, अपनी फीलिंग को एक्चुअली एक्सप्रेस कर सकते हैं। ठीक है, वही हमारा लैंग्वेज होता है। मतलब हिंदी, भोजपुरी और इंग्लिश से नहीं, सब भाषा एक समान है, जिससे आप अभिव्यक्त कर सकते हैं वही आपका भाषा है। ठीक है, तो नाउ वी विल कम टू द पॉइंट, मैक्सवेल्स लॉ ऑफ थर्मोडायनेमिक्स। ठीक है, so today we will discuss about the Maxwell's law of thermodynamics, and we expect that you have the basic information of first law of thermodynamics and second law of thermodynamics, and this must be okay. So just without wasting any time, let us start. We must be expecting that you must be knowing about first law of thermodynamics. We know what we know. We know from first law of thermodynamics, first law of thermodynamics, what do you know actually? You know dq is equal to du plus dw, where you must be understanding that dq is the change in heat energy and du is the change in internal energy and dw is the change in work done. Okay, this is the mathematical statement of the first law of thermodynamics. Now we can write dw in the terms of pdv. So this can be written as dq is equal to du plus pdv. It's okay? Are you comfortable? dq is equal to du plus pdv. Now using the second law of thermodynamics, we can use second law of thermodynamics. From second law of thermodynamics, or we can say from the definition of entropy, from the definition of entropy, it means we can say from second law of thermodynamics, okay, what we can say, let us assume that this equation is to be equation number 1, and from the definition of entropy we can give ds is equal to what, dq by t, not dq by dt. Okay, dq by t we can give. Okay, so entropy ds is defined as dq by t. So what we can give about dq? dq can be written as tds. In terms of entropy, it can be written as tds. It's okay. First we have used first law of thermodynamics, and then in the next step we have just used the basic definition of entropy, which can be given as ds is equal to dq by t. So we can write dq is equal to tds. Okay, so we will use this definition in the first equation using in 1. यूजिंग इन वन में इस्तेमाल करेंगे हम लोग. यूजिंग इन वन, what we can write TDS is equal to DU plus PdV. Okay, now TDS, now what we can write DU is equal to TDS minus PdV. Keeping this side, just take this term PdV this side, you can write in this way, TDS minus PdV. Okay, then we can say that DU can be written in this term. In terms of entropy, we have written internal energy. Let this equation be equation 2. It's all clear? DU is equal to TDS minus PdV. In this equation, both law, that you can say first law and second law, has been properly applied in the mathematical form. Okay. Now du is equal to TDS minus PdV. We can see that du is a total differential of internal energy. In the mathematical form, you can read that if u is a function, then it is written as not a perfect, it is also a perfect differential, but it is written as a total derivative. Okay? Total derivative. ds is also written as total derivative of the entropy. dv is written as total derivative of the volume. And if there is any function, then its total derivative can be written as what? df, and their partial derivative can be written as what? dou f. It's a symbol of partial derivative and it's a symbol of full derivative or total derivative. Total derivative can be written in the terms of the partial derivative, which we will use that. Okay. Now just let me erase this. It is not of use here. So are you comfortable with this? du is equal to TDS minus PD. Okay. Now we will use the definition of total derivative. Just let me say in the rough space, actually you can say total derivative of any function. Total derivative of any function. Total derivative of any function. Okay. Just not I am taking here. Let me take here and I will just erase further. Just let me write here only. Let me take proper space, and after that I will delete this. Delete whatever the mathematical statement or formula I have written, I will just delete it or clear it out. So I am discussing some basic mathematics, that is if f is any function, if is any function dependent on x and y, then how we can write? We can write as f as a function of xy. Okay. Now its total derivative can be written as df, and this total derivative in terms of partial derivative can be written as dou f by dou x into dx plus dou f by dou y into dy. If f is any function dependent on the variable x and y, then the total derivative can be written in the terms of partial derivative in this form. Okay. So in the same way, du, ds, dv can be written in the partial derivative form. If we decide on which term they are dependent, then we can write in the terms of their partial derivative. This is the mathematical treatment. Okay. But here function is physically internal energy, entropy and volume. So we will apply the same concept here also. Okay. So let me rub it or let me clear it, because it is of not direct use in this equation. Okay. We will use the concept only. So let us suppose that let u s v depend on thermodynamical variable, variable x and y. This x and y can be pressure, can be volume, can be temperature, can be entropy, etc. Okay. So we will further decide that which thermodynamical parameters should be taken in place of x and y. But this x and y can be thermodynamical terms taken from the pressure, entropy, temperature, volume, etc. Okay, here we are just giving as a mathematical name as x and y. Further we will give its physical meaning actually. Okay, okay, then we can say u as a function of dependent on xy. In the same way, s can be written as a function of xy, and v can be written as a function of xy. Okay, is it clear? Is it clear? Okay, then in the same way what we have discussed, just if we know any function is dependent on two variables or any other variables, their full derivative or total derivative can be written in the terms of their partial derivative. In what manner? In this manner, what I had discussed earlier, just du. Full derivative can be written as full derivative of internal energy. Okay, can be written as what? Can be written as dou u by dou x, dou u by dou x into dx plus dou u by dou y into dy. Is it okay? Is it comfortable? Okay. Here no need to say when we are differentiating u with respect to x partially, at that time, at that moment, y will remain constant. So we can represent in this way also. It's just information which we can already understood. Okay, dou u by dou y, the moment we are differentiating u with respect to y, at that moment x should be kept constant. So x should be kept constant. It's just a formal way of writing. It's not the hard and fast rule that we must have to write. It's not like that. Okay, if we write, we are giving extra information. If we don't write, it's self-understood. In the same way, we can write, what we write? We can write ds. Full derivative of entropy can be written in the terms of x and y as dou s by dou x. Now you must be understanding, into dx plus dou s by dou y into dy. Here we can give extra information that y is constant at that moment and x is constant at this moment. But if we give, it's well and good. If we don't, we give, it's not wrong actually. Okay. Now we can write also dv as a partial derivative dou v by dou x into dx plus dou v by dou y into dy. It's okay. Are you comfortable? Now we will use this total derivative in terms of partial derivative in the above equation 2. Okay, in the above equation 2, there was term du. You must be knowing. There was term ds. There was term dv. We will put this value in that equation, which is equation number 2, where it is given. Here it is. Equation number 2. See, du, ds and dv. In place of that, we will put this total differential in terms of partial derivative actually. Okay, so let us put it and see what happens. What happens? Using in equation 2, du can be given as what? Dou u by dou x. Let me write little short because the equation will be very lengthier actually. So let me write here dou u. Is it clear? Okay, dou u by dou x into dx plus dou u by dou y into dy. We have written in place of du. Okay, du we have written the term in terms of partial derivative. It's okay. Now what it was? Du tds. Du is equal to tds. In terms of, in place of ds, in terms of partial derivative, what we can write? We can write what we can write? Just a minute. We can write in place of ds as dou s by dou x into dx plus dou s by dou y into dy. Are you comfortable? Minus, what was the next term? pdv. Here we will write adjust. Just I was telling that the equation will be lengthier. That's why I had given a space actually. into dx plus dou p by, sorry, not p, it's a v, it's a v, it's a v, dou v by dou y into dy. Are you comfortable? Keep patience actually. This derivation is little lengthier and you are studying the topic of graduation. You are not understanding or discussing, just we are discussing the topics like 8th class standard or 10th standard. Okay, it's a higher level topics, so you have to keep patience. You know, you have to keep patience. The derivation will be lengthier because it has more explanation. You are at the higher standard, so you will see so many derivations which can take 5 pages, 6 pages, 8 pages or even more actually. So keep patience. The derivation will be longer, but every steps will be clear. Every steps, every single step will be clear, and the final conclusion what we will achieve or reach will be termed as general form of Maxwell's law of thermodynamics. General form of thermodynamics. So you know, in the general form we have to discuss a lot actually, and after getting the Maxwell's law of general form, we will get 4 law actually, putting the spatial value or physical value of x and y. We will see further actually. Just we are working on Maxwell's law of thermodynamics in general form. In general form, just okay. So now we will discuss what we will discuss. We will separate the term dx in one place and dy in another place. What we are going to tell actually, just you see here there is term that has coefficient in terms of partial derivative, which is dou u by dou x. Here we can collect the term of dx. Dx term is in this term, so we will collect it. And we can write as t dou s by dou x. Just be careful and keep watching. Minus p dou v by dou x. What we have done? We have just taken the term. What we have taken the term? We have just taken the term of dx. The dx term was here, the dx term was here. Okay, we have just collected it at one place. Are you comfortable? Okay, minus what we can say, minus not plus, take it plus. Now we will collect the term of dy term, dou s by dou y, into dy. Okay, minus it's will be multiplied with t. Oh, it's okay. It will be multiplied with t. Okay, minus p dou v by dou y into dy. Okay, is it okay? Now what we can say, we will separate it clearly. T dou s by dou x minus p dou v by dou x. This will be term of dx. Okay, so it can be compared with this side. This term can be equated with dou u by dou x if equation is valid, and equation is indeed valid. Okay, plus what we can write? We can write as t dou s by dou y, minus p, minus not a, yes, okay, minus p dou v by dou y into dy. It's okay, into dy, not it will be in common actually, it will be in common. Just let me write, it's a dy. Is it okay? We have separated the term of dx, we have separated the term of dy. Okay, now we will further move. If equation is valid, which is indeed valid and of course valid, so we can compare the both side. It means we can write dou u by dou x is equal to this value, dou u by dou y is equal to this value. Okay, so we will write it, just keeping it here because it has taken is a little bit longer. Just I am moving it, you must be noting, otherwise you can scroll down or you can play back the video. Just I am writing just dou u by dou x. So we can write, what we can write? We can write by comparing by comparing both sides of the equation, So we can write, what we can write, dou u by dou x is equal to P dou s by dou x minus P dou v by dou x. Very smooth, very clearly we are moving forward. Dou x, okay. Dou u by dou y can be written as T dou s by dou y minus P dou v by dou y just we were comparing. So we comparing the coefficient of dx and dy, we can write dou u by dou x is equal to this much, and dou u by dou y is equal to this much. Let me just examine if I am not okay. Dou u by dou x, it's okay, okay. Just be confirm if you have some silly mistakes or pen mistakes. Depending on that equation, you are moving forward. If you have done any single mistake, then the whole equation will go wrong further, okay. So just keep on examining in between when the derivations are long, okay. It's like just a story. Derivations are like a story, okay, in which we are just explaining some mysterious behavior of nature, some mysterious things happening in the nature, okay. Now what we will do, let us tell this equation, 3 and equation this as 4. Let us name it so that we can call it, okay. Now differentiating, just let me write in the proper way. Now differentiating partially, it must be kept in the mind that we are differentiating partially, okay. Now differentiating partially, equation 3 with respect to y and equation actually, and equation 4, actually we will need to use that equation also further. So let us name that equation also. Just what we are telling, just give the name of this equation. As equation number 3. What equation? This equation we have given now. These equations, let us name it 3 because we have to use this equation also further. So without writing this equation repeatedly or second times or third times, we can call it by their equation name. So let us name it equation number 3. So by that order, that can be considered as equation number 4. Let us decide it. It should be called as equation 4 and it should be called as equation 5, okay. Now so that's yes, okay. Now that equation, which is equation number 4, now it has become equation number 4 and it will be equation number 5. So just let us tell, I have just given the name equation number 3 to that equation, previous equation, and equation number 4 to this equation, and equation number 5 to this equation, okay. So that we can properly call it. We don't need to write again and again that equation. That's why we give just proper name or numbering actually, okay. So now differentiating partially equation 4 with respect to y, the equation that was earlier differentiated with respect to x, just here the equation that was earlier differentiated partially with respect to x should be differentiated again with respect to y, and the equation that was earlier derivative with respect to y should be partially differentiated again with respect to x, okay. Equation 5, equation 5 with respect to x. Are you comfortable? Just let me repeat it. The equation that was earlier derivative with respect to x was different, now is going to be differentiated with respect to y, and the equation that was earlier differentiated partially with respect to y, now again we will differentiate it with respect to x. The equation that was with respect to x will be differentiated again with respect to y, and the equation that was differentiated with respect to y earlier, the derivative was with respect to y, now we will be differentiated partially with respect to x. Are you okay? Comfortable? Okay. I am trying my best so that you can understand properly the every equation, the every line of the derivation. Okay. Now again differentiating, it means just see here what it is actually. Here the equation is equation 4, which will be differentiated as, what will be differentiated as? With respect to y. So the equation will be given as what? Dou u by dou x. It should be differentiated with respect to what? Y. With respect to y. Is it visible? Yes, it is visible. Is it visible? Okay. This equation is differentiated with respect to y. Now what we can write? This equation, just see. We will differentiate it dou by dou y, this whole equation, t dou s by dou x, minus p dou v by dou x, This equation will be differentiated again with respect to y. That was earlier derivative of x. Okay. Now we will start differentiating. Use u into v. Use u into v because this is also function, this is also function. So we will use product rule actually. Okay. So each term will produce what? Two separate terms, u into v, differentiation of u into v, you know. So just we can write what? Keeping this term temperature as constant, dou s by dou x. It will be differentiated once again with respect to what? With respect to y. It was earlier with respect to x and now with respect to y, so it will become double derivative. Double derivative, earlier it was with respect to x and now with respect to y. So it can be written as like this. Let me clear it. Keeping the term temperature constant, the first term as a constant, second term is differentiated and second term is differentiated again, so it's a double derivative actually. Okay. Now plus this term, the first term, this term is again keeping the dou s by dou x as constant. This term is making constant. This term will be, the first term will be differentiated with respect to y. Okay. So u into v, product rule we have used. First we have taken this term as constant, differentiated this term. In the next step we have just kept it constant and differentiated this term, temperature. Okay. Now we will differentiate this term using u into v. Okay. So keeping the term p constant, we will differentiate v. Okay. Again with respect to y. First it was with respect to x. Now we are differentiating with respect to y. Okay. So dou v by dou x, double derivative of v with respect to x and y. Okay. This is double derivative plus keeping dou v by dou x as constant, dou p by dou x. Sorry, not dou p by dou x. We were just differentiating with respect to y. Is it clear? Is it comfortable? You need to be concentrated actually. Okay. The equation is very clear. Now we will just take all this term with a great precaution so that we should not make any calculation mistake or any sign mistake. Now we will write this equation as double derivative. This will be written as double derivative of u with respect to x and then with respect to y. We read in this way actually, with respect to x and then with respect to y. Okay. Now it can be written as t double derivative of s with respect to y with respect to x plus dou s by dou x, dou t by dou y. Okay. Minus what? Double derivative with respect to this, and this minus will be minus dou v by dou x, and dou p by dou y. Okay. Is it okay? Minus, we have just multiplied it. Now let us call this equation as, we were just written equation number 5. Let us call this equation as equation number 6. Don't be panic. Be comfortable. The equation is long but simpler and it is very much clear also. The equation is indeed long, not so much long, but just little bit long, but it is easily written. It's not a tough way, or it's not the tough equation actually. What we have just done, we have applied the basic rule of calculus actually. In terms of physics, we have just used the basic rule of calculus, the product rule, okay. Each term created two terms, that's why we got four terms actually. Let us this equation be called as equation number 6. Now what we are told now we will differentiate the equation number 5 with respect to x. Let us make you to see what the matter is. This equation, which is equation number 5, now should be differentiated partially with respect to x. This was differentiated with respect to y, that we have assumed the equation number 6. Now this equation should be differentiated with respect to what? With respect to x, and that will be considered as equation number 7, obvious. So let me just write it, otherwise what we have written in terms of what we have written, just we will need to write it actually. Dou u by dou y is t ds by dou y, dou v by dou y, dou s by dou y, dou v by dou y. Just let me write it. Since dou u by dou y, now what we have to do now, work on equation what? Equation 5. Equation 5, dou u by dou y is equal to what we had written, t dou s by that was something minus p, or this dou v by something, okay. Just let me see what was something. That something was with respect to y and with respect to y, t dou s minus p dou v, okay. The equation was dou s by dou y and dou v by dou y. Now what we are going to do, we are going to differentiate with it partially with respect to x, okay. So differentiating with respect to x, so differentiating partially, that must be kept in mind, partially with respect to x, then we will write what? As double derivative of u dou x dou y, okay. First it was derivative with respect to y, now we are differentiating with respect to x, that can be written in this way and you can read that way, okay. Now we will do the same thing, but now we are just using directly, okay. We will differentiate it, two terms will be created. One term will be t differentiated dou s by dou y with respect to x, double derivative of s with respect to x and with respect to y okay. Another term will also generate dou s by dou y, keeping constant we will need to differentiate t with respect to what? X. This term will be created. We are differentiating directly, we are not writing the steps. Minus what we will do, we will differentiate this also with respect to x. Earlier it was with respect to y, now we will differentiate with respect to x. This term will come out like this, and dou v by dou y keeping constant, we will differentiate p with respect to x, okay. Differentiating both sides with respect to x, this equation will come out, okay. Let this equation be equation number 7, okay. Are you comfortable? Okay. Now it's equation number 7 and equation number 6, that should be written. This equation number 6 and that equation number 7 should be written in terms of what? In terms of whatever I had taken earlier, equation number 5, not equation number 5, it was I think it was equation number 4. We will use it, equation number 6 and 7, that equation that was earlier written as in the form of full derivative, or that was written later as partial derivative. In that equation we have to put this equation number 6 and equation number 7. What we are saying, just let me tell you from this way also. That equation number 6 and 7 should be placed in this equation number 3. It was named as equation number 3. In this equation we can place the term dou u by dou x and the term dou u by dou y, okay. That needs to be no need to place it. because we will here no need to place it actually. No need to place it actually. No need to place it. In order to get general form, we don't need to place it actually. Okay. We will just compare it. Equation number 6 and 7. Just see what we have tell. We have used the equation number 3, but we will not again put that. Okay. What we will do actually, we will use this equation number 6 and equation number 7. Okay. This equation number 6 can be equated with this equation number 7 on the ground that U, S, V all forms perfect differential. This equation number 6 and equation number 7 can be equated on what ground? On what ground? Actually, just let me tell you. Since U forms perfect differential. You can say V, S, T, P forms perfect differential. Perfect differential. What it means actually, perfect differential? You must be knowing, I am expecting that you must be knowing these basic things of differential calculus, but I am just repeating it because it's just a simple thing and short, that's why I am repeating. If something forms there are some function, suppose there is some function f which forms perfect differential. Let's suppose f it's a function of x and y, then and forms perfect differential. What it means actually? And forms perfect differential. It forms perfect differential. It means you can write, what you can write actually? You can write the double derivative. First you differentiate with respect to x and then with respect to y. First differentiate this function f with respect to x and then with respect to y. It will be same. If you differentiate the same function first with respect to x, first with respect to y and then with respect to x, it will be same. If you reverse the order of differentiation, then the equation will remain same. What we are telling, just keep cool. Suppose there is a function, f is a function of x and y which forms perfect differential. It means if you differentiate partially the function with respect to x and then with respect to y, the equation will be same if you have differentiated that function with respect to y and then with respect to x. It means what you can say, the function if you differentiate the function first with respect to x and then with respect to y, the equation will be same if you differentiate with respect to y and then with respect to x. Okay, that can be written in this form also. So u, v, s, t, p also forms perfect differential. It means we can write their double derivative forms in terms of this also actually. Okay? What we are telling actually, this is the basic mathematics that I had just recalled you so that you can understand properly, but we are going to apply it in u, v, s, t and p. What it means actually? What it means? It means if it forms perfect differential, it's a perfect differential actually. If it forms perfect differential, it means double derivative of u with respect to y and with respect to x is equal to double derivative of u with respect to y and with respect to x, y. Okay. Double derivative of u with respect to x and y will be equal to double derivative of u with respect to y and then with respect to x. Okay. In the same way, we can write double derivative of what? Double derivative of v with respect to y and x is equal to double derivative of v with respect to x and y. If you change the order of differentiation, it will remain the same. There are some functions which can't be done like that. Just I am just giving one example. I am telling. You can say product of two vectors a dot b, dot product is reversible. It means a dot b is equal to b dot a. But you already know that in case of cross product, a cross b is not equal to b cross a. So there it needs not necessary that if you reverse the function it will remains the same. It is not necessarily the same way. I am telling that if a function is perfect differential, then it will follow this rule that if you differentiate that function with respect to x and again with respect to y, it will be same if you have differentiated it with respect to y first and then with respect to x. Am I clear? I have tried my best to make you clear, to make you understand clearly actually. Okay. Now what we will do? Double derivative of s with respect to y with respect to x is equal to what? Double derivative of s with respect to x with respect to y. Why we are doing this? Just you will understand why we are doing this actually. Okay. Double derivative of p with respect to y and with respect to x is equal to double derivative of p with respect to x and with respect to y. Okay. We will use this condition, or you can say the result, when we will be simplifying the equation number 6 and equation number 7. On this ground that this is equal, we can write that equation number 6 and 7 are equal. If du forms a perfect differential, it means equation number 6, what it is? This is differentiation of internal energy with respect to x and then with respect to y. And what is equation number 7? This is internal energy derivative with respect to y and then with respect to x. If it forms perfect differential, which obviously forms perfect differential, then this equation which should be equated. That equation, both equations should be equated because this term and this term are equal. So this term and this term will be equated. And while equating that, we will simplify it on the ground that this derivative term, double derivative of s with respect to y and then with respect to x, and double derivative of s with respect to x and with respect to y should be treated as equal. In the same way, this derivative and this derivative should be treated as equal. Okay. Now, we will do that. We will take it in the next page so that we can write this equation. Okay. Let me take next page actually, so that we can write this equation. We are going to equate equation number 6 and 7. It's a lengthier equation. So again and again scrolling up and scrolling down, it will be a little bit uncomfortable. That's why we are just taking the next page actually. Okay. The next page we will write this equation, saying one by one. This equation, double derivative of y with respect to x, this equation should be equated. So equating equation 6 and 7. Why we are equating? We have just explained it, why we are equating. So 6 and 7, it was what? With respect to x and then with respect to y. Double derivative of this equation, what we can say, what we are just telling, this equation should be equated with that equation. So this side will be equated with this side. So we will write this t double derivative of s with respect to y and then with respect to x. Just let me write it. Just a minute. Let me write it. T double derivative of s with respect to y and then with respect to x. With respect to x. T double derivative of with respect to y and then with respect to x. T, this side, t double derivative of s with respect to y with respect to x plus what it was, the another equation, it was t dou s by dou x dou t by dou y, dou s by dou x dou t by dou y, dou s by dou x dou t by dou y. Just it is a long equation, that's why we will need to write it. Minus p double derivative with respect to y and with respect to x, double derivative with respect to y and with respect to x. Okay. Double p double derivative of v with respect to y with respect to x, and the another equation was dou v by what it was actually, dou v by dou x and dou p by dou y, dou v by dou x and dou p by dou y. Okay, we are just arranged and written in this. This is equation number 6. This should be equated as, this is little bit longer equation, so we will not write in one line actually, otherwise it will go beyond the board actually. Okay, so what we are, am I clear now what I am going to do? We are just equating the both equation. Okay, so equation number 6 has been written. Now we will write the equation number 7. This is t double derivative with respect to x and with respect to y. T double derivative is with respect to x and y equal to t double derivative of s with respect to x y minus dou t by dou x, you can say dou t by dou x and dou s by dou y. It's okay. Just let me clear it. Dou t by dou x and dou s by dou y. Dou t by dou x, dou t by dou x, dou s by dou y. Just we have reshuffled it. It's no matter. It's nothing to do. Okay. Now we will write that. What we will write minus this term p double derivative of v with respect to x and y. P double derivative of v with respect to x and with respect to y minus dou p by dou x. It was written as dou p by dou x. It is dou p by dou x and dou v by dou y. It's okay. We have just written that equation. Equation number 6 is equated with the equation number 7. Just let me match it, and you also must be observing that equation number this is t or s or t or s or t. Okay. Now p dv p. Okay. Now that equation s t dou s s t dou x. Okay. S t dou s and v and dou p by dou v. Okay. Now we had written it. In exam you must be writing in the paper, so you have the paper so that you can just turn the page or just see up and down. Here we had to write in the next page, and that's why I had to, what I have done that in order to skip the, what you can say, scrolling up and down, just I had taken the another screen actually. Okay. Another screen means another page on the same screen actually, not another screen or other computer actually. Okay. Now what we will do, now we will simplify it. It's okay. Just we have arranged it. It's a little bit lengthier equation actually. If you write in one line, it will be lengthier actually. Okay. Now we will simplify it since what we are telling, since s also forms perfect differential, so differentiating it with respect to y and then with respect to x will be equal to what? Equal to differentiating x and then with respect to y. On that ground it will be cancelled out. This will be cancelled out. Now this will be also cancelled out because we also form perfect differential. So if we differentiate volume v with respect to x and then with respect to y, it will be equal to v if you differentiate with respect to y and then with respect to x, being the perfect differential. So it will be also cancelled out. Am I clear? We are just cancel out the equal terms. The equal term, this term and this term. This term is in equal to of this term. So this term and this term are equal. That's why we had cancelled this term and this term are cancelled. Okay. Now we will simplify it. Just let me write here. Now we have the equation dou s by dou x, dou t by dou y, minus dou v by dou x and dou p by dou x. Okay. Equal to what? This is also lengthier, little bit lengthier, not much lengthier but little bit lengthier actually. Dou s by dou t, this is minus and it is also in the minus. So minus term is going to be here it is not in minus, it is to be in the plus. In the plus, in the earlier equation it was must be in the plus actually. It was in the plus. That's why we had just done a silly mistake, pen mistake it was. So we will write dou t, it's plus dou t by dou p is equal to this. Okay. Now this side dou t by dou x and dou s by dou y minus dou p by dou x and dou v by dou y. That side it is visible now? Yes, it's visible. Okay. So we have got this equation. What this equation is? Dou s by dou x product dou t by dou y minus dou v by dou x product dou p by dou x is equal to that. This equation is known as the general form of Maxwell's law of thermodynamics. Okay. So we will arrange it in the proper way actually. We will arrange it proper way, then we will talk further. So you must be enjoying this equation. We will write it in the proper way. In the what proper way we will write? We will write this as dou s by dou x, dou t by dou y. Okay. Dou t by dou y minus dou v by dou x, dou p by dou x. You can add some information also. What you can add? While differentiating s with respect to x, we were keeping the term y constant. So we can describe here y. While differentiating the temperature with respect to y, we were doing? We were keeping the term constant x. So we can write in the proper way as like this. Okay, this is wrong. Okay, dou v by dou x, somewhere I had done mistake actually. Here must be some mistake. This term will be not like that. There is some mistake. Dou s by dou x, this term is okay. This term is okay. Dou p by dou x, this term I had written. What I had written? This must be some other term. What we had written? There must be some y or x. Dou v by dou x, dou p by dou y. Dou v by dou x, dou p by dou y. Dou p by dou y. Just let me. It's a plain mistake, and you have to be careful in the exam also. But that might happen sometimes. Dou p by dou y, here it is. Dou p by dou y. So let me correct other way, other place also. Dou p by dou y. Dou p by dou y. Now it's okay. Now it's okay. Okay. Sometimes such plain mistakes can happen, but we have to be careful to avoid such mistakes. But in the long derivation, such types of things sometimes happen. Okay, dou s by dou x, but if you understand the things, you will just sort it out where we had done plain mistake. Dou s by dou x, that time y were constant. Dou t by dou y, that time x were constant. Dou v by dou x, that time y will be constant. Dou p by dou y, at this time x will be constant. Equal to what? Equal to this. Dou s by, you can write this term dou s by dou y first, and this term dou t by dou x. Okay, this term I had written dou s by dou y, this term dou t by dou x. At this time dou s by dou y, x will be constant. At this time y will be constant. Okay, just let me slide it here. Dou p by dou v by dou y, dou v by dou y, and this dou p by dou x. Just we have rearranged, and y, x will be constant, x, y will be constant. This equation, this little bit lengthier, longer equation is known as Maxwell's general form of thermodynamics. Maxwell's general form of thermodynamics. Let me check it out. Dou s by dou x, dou t by dou y, dou v by dou x, dou p by dou y, dou s by dou y, dou t by dou x, dou v by dou x, dou v p by dou x. This equation, this is little bit lengthier or longer, but this is the general form of Maxwell's law of thermodynamics. This equation is known as Maxwell's general form of thermodynamics. Let me write it. Maxwell's general form of thermodynamics. You must be remember general form. It's a general form of thermodynamics. It's a general form of thermodynamics. General form of thermodynamics. Okay. So it was little bit longer, but every step was clear. It's okay. Every step we had followed some simplified rule, but in the mid actually some steps were what got it after expanding, it got some little bit lengthier. But after that some simplification has been done, and we got some result which is also a longer equation, you can say. So, but whatever there, it is a longer or shorter, whatsoever be, this is Maxwell's general form of thermodynamics. From this Maxwell's general form of thermodynamics, we can derive Maxwell's 4 law of thermodynamics. and it's just coincidence that in the electromagnetism also Maxwell gave 4 law. Actually Maxwell's gave 4 law in electromagnetism also, and in the thermodynamics also Maxwell's given a 4 law of set of equations consisting of 4 differential equation, which is also known as Maxwell's 4 law of thermodynamics. But now what we have done, we have derived Maxwell's general form of thermodynamics. It's a general form actually. Why we call it general actually? Because we have not fixed x and y. What is x and what is y? X and y will be selected from the thermodynamical term S, T, P or V. Entropy, temperature, pressure and volume. It will be selected out of that. Sometimes you will select x as entropy and then y as volume, and other time we will select temperature as the first function and the second function y as what we can say that volume or pressure as another function. We will do that later, selecting x and y from temperature, entropy, pressure and volume, and we will form the set of 4 equations. Okay, that will be the next topic. So you must be just it was a lengthy equation, and I hope that every phase you must have understood it. Okay, थोड़ा सा हम भी रिलैक्स हो जा रहे हैं एक्चुअली, क्योंकि लगातार बोलते ही गए, ठीक है, करते ही गए। आप तो आराम से जो है सुन रहे थे। हो सकता है कुछ लोग बेड पे बैठे हो, सोए होंगे, आराम से इसको देख रहे होंगे, भगा भगा कभी आगे करके कभी पीछे करके, एक्चुअली कभी कुछ करके जो है, ठीक है। हम तो लगातार एक्चुअली जो है क्या करते चले गए, आपको डेराइव करते गए, ठीक है। तो आप उम्मीद करते हैं एक्चुअली कि आप इस डेरिवेशंस को जो अच्छी तरह से समझे होंगे। ओके, और दूसरी बात एक्चुअली ये है कि आप हमेशा जो है डेरिवेशन वगैरह जब करते रहते हैं तो आप ऐसे तो समझने के लिए जो भी करते रहिए। आप इसको देख रहे हैं, अब आप सो करके देख रहे हैं कि पहने उड़े हुए हैं कि नहीं पहने उड़े हुए हैं, तो नहीं मालूम है एक्चुअली क्या कर रहे हैं क्या नहीं कर रहे हैं, एक्चुअली ये तो नहीं मालूम है। लेकिन यदि आप डेरिवेशन को अच्छी तरह सीखना चाहते हैं तो अच्छा रहता है कि आप एकदम शांत होकर के, रिलैक्स होकर के एक्चुअली जो है पेन और पेपर लेकर के जो है एक एक करके स्टेप को जो है नॉर्मली लिखते हैं, ठीक है। और जब आप एक बार इसको अच्छी तरह से नोट्स बना लेते हैं तो उसके बाद फिर प्रैक्टिस करते हैं एक्चुअली जो, ठीक है। फिर प्रैक्टिस करने के बाद जब आपको लगता है कि नहीं इस इक्वेशन के साथ हम कंफर्टेबल हो गए, इसके हर एक स्टेप को समझ रहे हैं, तो फिर आप खुद से करिए एक्चुअली जो है। जब आप खुद से स्मूथली रूप से कर लेते हैं पूरे रास्ते को जो है, ठीक है, तब इसका मतलब है कि आप डेरिवेशन को अच्छी तरह से समझ रहे थे, वरना कहीं स्टक कर जाइएगा अचानक, ठीक है। 2 स्टेप 4 स्टेप चाहिएगा और स्टक कर जाएगा। तो ऐसे पॉइंट को जो है नॉर्मली आप कोशिश करते हैं पहले समझने के लिए, ठीक है, कि आखिर वहाँ पे क्यों स्टक हो रहे हैं। वो स्टक इस वजह से तो नहीं हो रहे कहीं मिस्टेक कर दिए हैं, या कहीं ऐसा तो नहीं कोई कॉन्सेप्चुअल मिस्टेक आप कर दिए हैं, या कहीं ऐसा तो नहीं नॉर्मली कि कुछ चीज़ों को आप भूल ही गए बिल्कुल तरह से, ठीक है। तो आप सॉर्ट आउट करते हैं, ठीक है। पेन मिस्टेक हो जाना एक नॉर्मल बात हो सकता है, लेकिन आपको जो है चीज़ें समझ में आना चाहिए, ताकि आप कहीं पे हल्का बहुत डिस्टर्ब भी होते हैं तो आप उसको सॉर्ट आउट कर सकते हैं एक्चुअली जो है, ठीक है। हाँ, कंसेप्चुअली आपको जो है बातें समझ में आ रही, कंसेप्चुअल मिस्टेक्स नहीं होना चाहिए, ठीक है। चीज़ों को समझा हुआ रहना चाहिए पूरी तरह से, जो हर स्टेप आपको जो है क्लियर रहना चाहिए, ठीक है। तो आपको मालूम कैसे चलेगा, जब आप करिएगा एक एक करके, आप जो है कलम से आप नोट पे बैठ करके आराम से जो है नॉर्मली करना स्टार्ट करिएगा, तब जा करके जो है आप इस बात को क्लियर हो पाइएगा, ठीक है, कि कौन सा स्टेप में आपको जो है प्रॉब्लम है, ठीक है। हमने तो पूरा कोशिश किया है एक्चुअली कि हर स्टेप को एक एक करके क्लियर रखा जाए, ठीक है। तो ये मैक्सवेल्स जनरल फॉर्म ऑफ थर्मोडायनेमिक्स हुआ। अब इसी के आधार पे हम लोग जो है मैक्सवेल्स 4 लॉ ऑफ थर्मोडायनेमिक्स को जो हम लोग डेराइव करेंगे एक्स और वाई को सेलेक्ट करते हुए, ठीक है। एक्स और वाई को जो हम लोग सेलेक्ट करेंगे वो थर्मोडायनेमिकल पैरामीटर्स पहले भी एक्चुअली बोल रहे थे, ठीक है, कि एक्स और वाई जो है थर्मोडायनेमिकल पैरामीटर एंट्रोपी, टेम्परेचर, वॉल्यूम और प्रेशर, इसी में से सेलेक्ट करेंगे। कभी एस को एक्स के रूप में मानेंगे और उसके बाद जो है हम लोग फिर जो है वी को मानेंगे वाई के रूप में, और उसके बाद देखेंगे कौन सा इक्वेशन इसमें पुट करने के बाद क्या सिंप्लीफाई फर्दर होता है। और इसी तरह से 4 सेट जो एक्चुअली जो है क्रिएट होते हैं, जिसको हम लोग मैक्सवेल्स 4 लॉ ऑफ थर्मोडायनेमिक्स बोलते हैं, ठीक है। तो उम्मीद करते हैं क्या जो मेहनत किया गया एक्चुअली उसका सही रिजल्ट भी हो, ठीक है। आप इसे सीखते हैं, ठीक है, और फिजिक्स से आपको इंटरेस्ट रहना चाहिए, और डेरिवेशन से आप भागते नहीं। ऐसा नहीं कि आपको जो लेंदी डेरिवेशन है तो आप एकदम डर गए एक्चुअली, जो है ऐसा कुछ नहीं, ठीक है। ग्रेजुएशन का डेरिवेशन है, जाहिर सा बात है लेंदी थोड़ा रहेगा ही, पैसेंस तो थोड़ा रखना ही पड़ेगा, क्योंकि हायर चीज़ों का है, आप 9 10th वगैरह में तो है नहीं, ऐसा तो नहीं कि 9 10th वगैरह में 2 स्टेप 4 स्टेप, या 11 12th में भी ज़्यादा से ज़्यादा क्या होता है, 1 पेज के आसपास में, 1.5 पेज ज़्यादा से ज़्यादा चला गया, उसी को लेंदी बोला जाता है। यहाँ तो नॉर्मली जो 1 1.5 पेज तो समझाने में लग सकता है, छोटा छोटा बातें जो साइड में रहा करता है एक्चुअली जो, ठीक है। और मेन डेरिवेशन को करते समय तो 7 8 पन्ने तक भी आपको जा सकता है, ठीक है। तो जाहिर सी बात है, हायर चीज़ों का आप पढ़ रहे हैं तो थोड़ा एक्सप्लेनेशन तो रहेगा ही रहेगा, जो है डिटेल में तो बातें रहेगा ही रहेगा, तो डेरिवेशंस भी आपको डिटेल में रहेंगे। अब यह बात ये जरूर रहता है कि आपको हर स्टेप यदि समझ में आता है तो पूरा एक स्टोरी टाइप का लगेगा, पूरा डेरिवेशन ऐसा लगेगा जैसे कोई स्टोरी चल रहा है, कोई पोएम चल रहा है एक्चुअली जो, ठीक है। आपको इस तरह का एहसास होना स्टार्ट लगे, एक अच्छा फील महसूस होगा, एक समझिए तो आपको एक डिवोशनल फील भी एक्चुअली आएंगे। क्यों डिवोशनल फील आएंगे? आपको लगेगा कि प्रकृति कितना सिस्टमैटिक ढंग से एक्चुअली बना हुआ है, जिसको हम लोग कितना सिस्टमैटिक रूप से डिस्क्राइब कर पा रहे हैं एक्चुअली जो, ठीक है। तो फिजिक्स एक माध्यम भी है इस ब्रह्मांड को समझने के लिए एक्चुअली। हमारे इर्द गिर्द या हमसे दूर एक्चुअली जो भी घटनाएं ब्रह्मांड में घट रहा है, जिसको हम लोग बोलते हैं कि बनाने वाले या अब जो भी XYZ या जो भी सुपर नेचुरल पावर या नेचुरल सिलेक्शन या गॉड या कुछ भी आप जो भी बोलते हैं, कुछ तो मानते हैं एक्चुअली जो है, ठीक है। कितनी अच्छी तरह से ये ब्रह्मांड एक्चुअली जो डिजाइन किए हुए हैं, इसके पीछे कितने अच्छे से लॉ एक्चुअली काम कर रहे हैं, ये जान करके आपको वास्तव में डिवोशनल फीलिंग एक्चुअली आएंगे, ठीक है। फिजिक्स सिर्फ आपको एक सब्जेक्ट की तरह नहीं लगेंगे, एक तरह समझिए तो आपको एक इमोशनल सेटिस्फैक्शन देना स्टार्ट करेगा, एक तरह से जो एक डिवोशनल सेटिस्फैक्शन। कैसे आप किसी चीज़ों को पढ़ते हैं, धार्मिक किताब को पढ़ते हैं, कुछ धार्मिक कार्य करा करते हैं, तो एक्चुअली क्या मिलता है आपको? एक सेटिस्फैक्शन मिलता है, एक रिलीजियस सेटिस्फैक्शन मिलता है एक्चुअली, कुछ अंदर से अच्छा महसूस होता है। वही सिचुएशन आपको फिजिक्स के साथ होने लगेगा यदि आप इसको समझते हैं कि आप प्रकृति को समझ रहे हैं, ठीक है। तो जो सृष्टि करता है एक्चुअली, जो भी XYZ एक्चुअली, जो भी आप उनको नाम देते हो अपने अपने धर्म के हिसाब से, आप उनके सोच को, आप उनके कलाकृति को आप बोल सकते हैं, उनके डिजाइन को एक्चुअली आप देखते हैं, ठीक है, समझते हैं फिजिक्स के माध्यम से। ओके, तो हम लोग नेक्स्ट टॉपिक के साथ फिर मिलेंगे, तब तक के लिए थैंक